Kia ora, Year 12. This is a question from the May-June 2021 A-Level Pure paper, and this is a request from Max, and it's a really good question to look at. It's got, first of all, some differentiation and then some integration. So I'll look at the whole question first. And sorry about the guitar noise in the background, but can't be helped. Right, so the diagram's given us quite a cool looking curve. We've got y is equal to the natural log of x over x to the power of 4, and you can see we've got a maximum point m. We have to find the exact coordinates of m, which is pretty straightforward, right? So that's 4 marks, and we're going to use, what am I going to do? I'm going to do product rule on that one. And that's only about 5 lines. And then the next part is to use integration by parts and to show that for all a greater than 1, that this integral is strictly less than 1/9. So it looks a bit funny, but it all kind of falls out, especially if you just do some careful thinking about when the log function is positive and when it's negative. So that's your clue for that question. So pause the video and have a go at both the parts, and then I'll work through them. Okay, so to find point m, we've got y is equal to the natural log of x times x to the negative 4. Dy by dx is equal to u dash v, so 1 over x times x to the negative 4 plus the natural log of x times negative 4x to the negative 5, and that equals 0 for a stationary point. So cleaning that up, I get this. I get 1 over x to the power of 5 minus 4 log x over x to the power of 5 is equal to 0. So I've already got my common denominator. That means that I've got 1 minus 4 log x is equal to 0. That gives us the natural log of x is equal to, going carefully here, so it's equal to 1/4. And x is equal to e to the 1/4. So that's the x value, but we're asked to find the coordinates. So now I need to take that and substitute it back in to get my y value. So let's do that now. Okay, y is equal to the natural log of e to the 1/4. Sorry, it's very noisy here at the moment. I hope you guys can't hear it all, but we've got all kinds of stuff happening, including the dog. Right, so the natural log of e to the 1/4 is 1/4 divided by e to the power of 1, which gives me a final very nice answer of 1 over 4e. So point m is equal to this. Okay, you don't have to write it like that, but it looks nice, so there you go. So that's the first bit. Right, now let's look at how we do the next part. Well, we're told to use integration by parts, but even if we weren't told to use integration by parts, hopefully at this point in the year, that's what you would choose. So let's integrate by parts and then see how we can say that it's going to be, the integral is going to be less than 1/9. Okay, so integrating between a and 1, we've got the log of x times x to the negative 4 dx. Right, now this is going to be hard to integrate, but this is going to be easy to integrate. So this is what I'll integrate, this is what I'll leave, this is what I'll integrate, and this is what I'll differentiate. And just watch out for your signs. Okay, so we've got the natural log of x, leaving that, and then I've got x to the power of negative 3, and I want that to have a coefficient of 1, so it needs to be times negative 1/3. Evaluated at a and 1, minus, right, the integral between a and 1. I'm going to differentiate this. So 1 over x times the integral of this, which we've already done. So it's times negative 1/3 x to the negative 3 dx. Right, let's clean that up. Actually, this was so straightforward here that I just went straight to evaluating it. So we've got the natural log of a times negative 1/3 over a cubed minus the natural log of 1, which is going to give me 0. Now here, let's take out the plus 1/3, and that's something that you weren't doing enough of in the school exam. So just clean your constant up first. And here we've got 1 over x times x to the negative 3. So we need to integrate x to the negative 4. So that gives me negative 1 over 3a cubed times the natural log of a plus 1/3 times, so integrating this again, we get negative 1/3 x to the negative 3 between a and 1. Right, giving us, we'll write it like this, negative log a over 3a cubed minus 1/9, so we can see that coming. Right, so now evaluating this, we've got 1 over a cubed minus 1 over 1 cubed. What we've got to do now is figure out how we can justify the claim that this is going to be less than 1/9 for values of a greater than 1. So we can clean it up a bit more first. I'm just going to leave that like that. And then we've got plus 1/9. So if we want this to be less than 1/9, what we've got to show is that this bit here is negative. So it equals 1/9 minus, common factor here is 1 over a cubed into 1/3 log a plus 1/9. Right, so there's nothing too hard about that. We've just got to watch out for our sign. So let's just go over that again. Here's my 1/9 here, and then here's my common factor, is that a cubed, so minus that, and then I've got the terms in there. Okay, so we're just about done. So for a greater than 1, we know that the natural log of a is a positive number, right? Think about your graph of the natural log. And that means that 1/3 log a plus 1/9 is strictly positive. And that means that 1 over a positive number times that is also positive, because a is greater than 1, so it's also greater than 0. So the integral is equal to 1/9 minus this, so it must be less than 1/9. So when you've got to work with proving an inequality, and you'll see this for those of you who go on and do the Canterbury paper next year quite often, the best place to start is with the restriction that you're given, and then just slowly work your way up. So you can see that logically what I did here is I said, well, what's the implication of a being greater than 1? Well, that means that the natural log of it must be positive. Then we just start to do things to that natural log. So we times it by 1/3, that's not going to change the sign. And then we're adding on a positive thing, and that's not going to change the sign. And then we're going to multiply it by something else, and that's not going to change the sign. And then finally, we've got the integral, which is equal to the constant we're after minus a positive thing. Okay, thanks for watching. The other question that's a really good one in this paper is question 7, and I'm going to video that shortly. So you can watch that later on.